Hey guys, we're going to learn about fractions and rational numbers. So let's get to work. All right, so we're doing fractions and rational numbers. Our question number 1, write 4 sets of fractions having 3 fractions in each set. Let each pattern block be the base unit for a set of fractions and show a fraction to relate each of the other shapes. So we're going to use a hexagon, a trapezoid, triangle, and a rhombus or rhombi. All right, for a hexagon, it's going to take, grab our little hexagon, we have 2 trapezoids. 2 trapezoids is equal to 1 hexagon. Now, let's see how many triangles we have. 2, 3, 4, 5, 6 triangles equals 1 hexagon. Now for rhombus or rhombi, we have 1, 2, 3, and 4. So 4 rhombi equals 1 hexagon. All right, we're going to try a trapezoid. Now for a trapezoid, there's a half of a hexagon is equal to 1 trapezoid. For the triangles, we have 1, 2, 3 triangles equals 1 trapezoid. Let's see how many rhombi. We have 1, there's 2, but for 1 trapezoid, it's 3 halves of a rhombi, or 1 and 1/2, if you're doing mixed numbers. For a triangle, 1 triangle is 1/6 of a hexagon, and we have, for our trapezoid, 1/3 of a trapezoid is equal to 1 triangle. And half of a rhombi is equal to 1 triangle. Now we have a rhombus, or rhombi. 1/3 of a hexagon is equal to 1 rhombi. Now for a trapezoid, there's 2/3 of a trapezoid is equal to 1 rhombi. And then for a triangle, we have 2 triangles is equal to 1 rhombi. Now I explained how you would figure out each problem. You guys can go through that on your own. For question 2, a man bought a length of rope at the hardware store. He used 1/3 of the rope to make a bow painter for his canoe, and then used 1/4 of the remaining piece to tie up a roll of carpet. He now has 36 feet of rope left. What was the length of rope he had originally purchased? Okay, so all right, so he's got 36 feet of rope left. So he used 1/3 of it for the bow painter, which is about right here, is what I'm estimating. Okay. Now he used 1/4 of it to tie up the carpet, which is about right here. Okay. So now what we need to do in order to solve this problem, we're going to have to cut the remaining parts into 3 equal pieces. So we'll say about, that's not really equal. So we got 3 more pieces. All right, so in order to figure this out, we know he has 36 feet of rope left. So we're going to divide 36 into 3. No, we're going to divide 3 into 36, sorry. So each part that's left is equal to 12 feet. Now we can divide this into, let's see, we have 1, 2, 3, 4, 5. Oh, that's not right. Supposed to have 8 sections. I messed up on my calculations, I'm sorry. We all make mistakes. So we're going to have 8 sections of rope, and 8 times the amount each section is, which is 12 feet, gives us 96. So he originally had 96 feet of rope to start out with. And again, here's directions on how to do that. All right, now question 3. Represent each of the following fraction functions with a fraction strip model and a number line diagram. Let me tell you, I kind of like these fraction strip models. Number lines, they're okay, I guess. All right, so here's our first one. We have 1/3 plus 1/2. Here's our 1/3, and here's our 1/2. Since we're adding them, I put them side by side. So kind of, you're combining them. Now, I did a step ahead. What you need to do in order to solve, because the denominators are different, you need to find the common denominator. So in order to do that, I know that 6 is the common denominator of 1/3 and 1/2 of 3 and 2. So whatever you do to the top, you've got to do to the bottom. So for instance, on 1/3, to get 6 in my denominator, I have to multiply 3 times 2. I have to do that to the top. So we have right here 2 6 right there. Okay, and then we got to get 6 over here in the 1/2. So 2 times 3 gives us 6. Do it to the top, 1 times 3. So it gives us 3 6. Oops, there's more. Sorry, guys. 2 6 plus 3 6. That's how I got these 1 6 up here, is equal to 5 6. As you can tell, my 1 6 is lined up with my 1/3 and 1/2. Now for our number line. All right, we got a 2 6 right there. So we start from here. We go 2 6 plus a 3 6, which is here, gives us 5 6. Okay, we'll do one more and then y'all should get the gist of it. We'll move on to the next problem. So we have 1/2 plus 3/4. Now again, we need to find the common denominator. Here's our 1/2 and there's our 3/4. Now I know from looking at this that 4 is a common denominator of 2 and 4. So I'm just going to add my 4ths. So we got our 3/4 from our problem. 1/2, to get that into 4, we got to do 2 times 2 at the bottom, which will be 4, and the 2 at the top, so it'll be 2/4. So I add 2/4 to this. So that gives us 5/4. And there we go. We have us working out our denominators. Okay, so let's do our number line. Down here at the bottom, we have 2/4. So we're going to add 2/4. And then we're going to go to 3/4. Oops, almost there. So here's our number 1. So we know this is more than a whole number. It's actually, when we reduce it down, it is going to give us 1 and 1/4. That's not very good, sorry. All right, so we know 1 and 1/4. All right. If y'all want, let's do one subtraction, so I know that y'all are getting the hang of it. So we have 3/4 minus 1/3. So here's our 3/4. Now I'm not doing like I did on the addition. I'm not putting them next to each other. I'm going to put them down below. And 1/3. Now 12, by looking at this problem, I can see that 12 is probably going to be our common denominator. So I went ahead and got 12 pieces. 1/12. And with them lined up, you can see my lining up is a little off, but you can see right here that it's about what's left. But here, we'll work it out together. So to get 12 in the denominator, we got to do 3 times 4, which gives us 12, and 3 times 3, because whatever you do to the bottom, you got to do to the top, is 9. And for our other one is 3 times 4 gives us 12, and 1 times 4 gives us 4. So 9/12 minus 4/12 is equal to 5/12. So let me see. There's my little paper. Anyways, okay, so we'll just do it. I'll try it from there. Okay, so we'll go to our 3/4. So we'll draw us a line all the way over here to our 3/4. Now we're subtracting. If you remember on our addition, both of them had an arrow, but on this one we're subtracting. So we'll go to our 3/4 and we're going to take away 1/3. Oh, so we'll go back all the way to here. And there's our problem on a number line. All right, the next one is the same situation. We're just subtracting. But here's the problem. I think after that example, y'all could work this one on your own. And here's steps of how to follow. Now, problem 4. Represent each of the following fraction function facts. That's a little tongue twister. With a fraction circle diagram and a number line diagram. Okay, now this one, we'll do a couple of these too, and then we'll move on to the next problem. So we have 3 times 1/5. So here's 1/5. Now how we work these is that 3 is telling us how many of these circle diagrams that have 1/5 we're going to need. So here's 1, there's 2, and there's 3. So that's 3 times 1/5. So 1/5 plus 1/5 plus 1/5 gives us 3/5. Now let's figure this out. Oh, I didn't do it on our number line, did it? Let's do our number line, silly girl. All right, so we'll go down here and say 1/5 and 2/5 and 3/5. All right, we'll do this one, and then I think you guys can do the rest, and we'll move on to the next problem because we got a lot to cover in this chapter. So here we go again, 3 times 2/4. So again, 3 is telling us how many circle diagrams we're going to have. So here's 1 2/4, 2, and 3. So we know we have 2/4 plus 2/4 plus 2/4, which is going to give us a whole and a half. So on our number line down here, we'll go, here's 1, 2, and 3. Are you guys getting the hang of this, or should we work on? We have a negative one. Let's do that one so you guys can see how to work it. Again, here we got 5, 5/8, same as what we just did. And here's the answer. We got 3 and 1/8. And down here on the number line, here's the 3 and the 1/8. Each one of these in between is a mark, just in case you guys didn't catch that. Here's our negative. We got -5 times 5/8. Now, this is similar to the problem that was just before that we didn't work, but let's work on this negative because some people might get a little confused and might mess them up. So again, that 5 is telling us how many of these circle diagrams we have. So here's 1, 2, 3, 4, 5. It gives the same answer as the other one. So we have 3 wholes and 1/8. Now this is where it gets a little tricky. We have our little number line down here. Now remember what I said, each in between is 1/8. I should have marked it on here, and I'm sorry that I didn't, guys. But I'm explaining now. Okay, so this -5 is telling us how far back we need to go. We're going to end up going from here. Let's see. So let's go 5. Here's 1, 2, 3, 4. Whoops. 1, 2, 3, 4, 5. 1, 2. There's look. Make our little tick marks. Okay. So we got 1, 2, 3, 4, 5. Do it again. There's 3 5/8. Then 1, 2, 3, 4, 5. Right here. And then we go 1, 2, 3, 4, 5. And there we go. We're just going backwards. So it's negative. If you notice the numbers down here at the bottom of the number line are negative. That's the only difference. And here's our steps on how to work them. Now here we go. This one's a little tricky. People look at it and be like, what are we doing? Well, let's break it down. A unit square is portioned into 7 tangram pieces, A, B, C, D, E, F, and G. What fraction gives the area of each piece? Now, if you look at our square here, fraction A, or area A and B take up half of this big square. Let's draw it out. Sorry, my lines are a little messed up, but look, it takes up half the square. So if we cut it into fourths, the square into fourths. All right, so now we know that A and B both are a quarter of the whole entire square. So over here we have A, area of A is 1/4 and area of B is 1/4. Now to find C, look over here at C. C is kind of a little guy, but we know this little area right here, C, D, and part of G is another quarter of the square. So if we cut D in half, like, whoop, that's in half, guys. So we got 1, 2, 3, we got 4 squares over here. So this whole thing is a fourth, and we got 4 right here. Each one of these, C and this part of G and D cut up, is going to be 1/16. All right, so now we know that C is equal to 1/16. To find D, we add 1/16 plus 1/16, which is going to give us 2/16, which in all actuality is 1/8. Now, area of E is the same size as C, so it's going to be 1/16. Now F, it looks a little scary, guys, but don't worry. It is still a little square, kind of like just a little shifted. So it's very similar to D. So again, it's going to be the same size as D, which is 1/8. And then G, believe it or not, it's just 2 little triangles the size of C and E. So G is also 1/8. And here's a step-by-step on how to do it. Let's move on to our last problem. Now this one is a little fun because, come on, who doesn't love some brownies? So if you have a list of ingredients for chocolate brownies that will make 16 brownies, use the list to decide how much of each ingredient is needed to make 12 brownies. So we don't want to make the whole 16 batch of brownies. So here's our ingredients listed below. Let's figure out how we're going to figure out how much of what we need to make our 12 yummy brownies. So in order to do this, you need to put the number of your desired serving size, which I have right here, is 12. So we want 12 brownies. So we put that, and then you put the serving size, the recipe serving size, down below. So when you have 12/16, you can simplify it to 3/4. Now to figure out what of each ingredient you need for your 12 brownies, you will multiply 3/4 by the ingredient that's listed for the 16 brownies. So right here for the butter, we have 3/4 times 2/6, which gives us 6/12. And when you simplify, because you really want to simplify it, who has a 12th measuring cup? You get 1/2. So you need 1/2 cup of butter for our 12 yummy brownies. Now for the chocolate, you multiply 3/4 times 5/1, which gives us 15/4. And when you simplify it, it's going to give you 3 3/4 ounces of chocolate for our yummy brownies. For the sugar, same thing, 3/4 times 3/2. 3/2 is 1.5 cups. Gives you 9/8, which is 1 1/8 cup. For your vanilla, same thing, 3/4, and it told us 2 teaspoons, but we put it in a fraction, so it makes it a little bit easier, which gives us 6/4, which is 1 2/4, and you simplify down to 1.5 teaspoons. Eggs, they wanted us to do 2 eggs, so we multiplied that by 3/4, which gives us 6/4, which is 1 2/4, and then 1.5 egg. For the flour, same thing, 3/4 times 1, of course, is just 3/4. So here's our ingredients for our 12 yummy chocolate brownies. So if you're making some, I would like one. And here's the step-by-step of how you work that problem, just in case you have any questions. Okay, so that is all I have for our problems. I hope this has been beneficial and has been helpful for you guys. Thank you for joining me.